Hello children, welcome back to the digital classes. I hope you are all doing well. You might be very much excited to learn some new concepts in this session. So let us start our session. Look at our school, Model School 𝗧𝗦𝗔𝗧 from Siddipet. Now let us take a look from the aerial point or from the top as shown. You can see our school and hostel, and there is some other building too. Can you see the shapes formed over there? Yes. And can you recognize these figures also, children? Yes. We call these figures as plane figures. The first one, if you notice, that is our school. If you notice, it is in the shape of a rectangle. Whereas the next one, it is our hostel building. It is in the shape of a trapezium. Whereas if you notice the other building, it is in the shape of a pentagon. Children, do you know what is the formula to find area of such plane figures? Take a look at this first figure, that is a rectangle. Area of rectangle is given by the product of its length and breadth, that is L into B. Whereas if you consider the square, the area of a square is side into side, that is S into S. Now take a look at this triangle with base B and height h. The area of this triangle is given by half into base into height. Have a look at another plane figure. This is a parallelogram. The base of the parallelogram is B and its height is h. Then the area of the parallelogram is given by base into height. Now children, take a look at the images shown on your screen. The first one is the lampshade, whereas the second one is a shopping trolley. Now take a careful look at these two objects, children. The first one, if you notice, and also the second one, if you notice, the outlines of these images, they are in the shape of, yes, trapezium. Children, do you know what is the formula to find the area of a trapezium? In our today's session, we are going to learn about areas of plane figures, in which we are going to deal with areas of various plane figures. So children, by the end of this session, you will learn area of a trapezium, area of a quadrilateral, area of a rhombus, and area of a polygon. So let us start with the first one, that is area of a trapezium. Have a quick look at the image shown on your screen. So here ABCD is a trapezium with diagonal AC. If you notice, the length of side AB is A, whereas the length of side DC is B. Children, if you notice here again, in a trapezium, the opposite side, that is one pair of opposite sides are parallel, that is AB and CD are parallel to each other. Now if you notice, we have drawn a perpendicular from C on E. This is called the height, or even it is called the distance between the parallel sides. We denote it as h. Now let us extend CD to F, and let us draw one more perpendicular from A on CD at F. Here we notice AF and CE both are equal to h, as they are distance between same parallel lines. Now children, let us find the area of this trapezium ABCD. So area of trapezium ABCD is equal to, yes, area of triangle ABC plus the area of triangle ADC. That means if we add the areas of these two triangles, we get the area of trapezium ABCD. Now let us find the formula for this area of trapezium. In the first one, that is area of triangle ABC, here base is AB and the height is C. So it is half into AB into C. Whereas in the second one, that is area of triangle ADC, I am taking base as CD or DC and the height will become, yes, AF. So it is half into DC into AF. Now let us substitute the values, children, here. That is AB value is small a and C is how much, children? Yes, it is h. Again we have half into DC. So we have seen DC is equal to B and AF is also equal to h. On substituting these values, we get half into A into h plus half into B into h. children, in these two terms, can you notice anything common here? That's right. We notice half is common, and anything else, children? You're right once again, that is h is common. Now taking half h common, we are left with a plus b. So we get half into h into a plus b square units. So this is the area of trapezium formula, that is half into h into a plus b square units. Let us analyze what actually it means. So notice that, children, here h is nothing but the distance between the parallel sides. Okay, and what are a and b, children? They are the parallel sides of the trapezium. So half into h, that is distance between parallel sides, into a plus b. A plus b is nothing but sum of the lengths of the parallel sides. So this is the area of a trapezium. Now children, we have seen the area of a trapezium. Let us apply this in solving few problems. Okay children, let us see. Now we have already seen this image, children. So that is our hostel. It is in the shape of a trapezium, in which one pair of opposite sides are parallel, and the length of the parallel sides are 100 meters and 85 meters, whereas the distance between the parallel sides is 80 meters. Now let us find the area of the hostel. So you can see the image, children. From that, the length of parallel sides a equal to 100 meters and b is 85 meters. And also the distance between the parallel sides is nothing but h equal to 80 meters. And recall that area of trapezium is half h into a plus b. Now let us substitute the values, children. Here h is equal to 80 and a is 100 and b is 85. On substituting it, I can cancel this one time and 40 times, right children? So how much you get? 40 into 185. On multiplying these two, you get 7,400 meters square. Hence I can say that the area of the hostel is 7,400 square meters. So next we will move on to our next one, that is area of a quadrilateral. So children, you can notice a figure here. It's a four-sided figure. So a simple closed figure with four sides is called a quadrilateral. So here ABCD is a quadrilateral, and what is this AC called as, children? Yes, AC is diagonal. So actually we can have one more diagonal also, but I have taken only one diagonal. Now this diagonal AC, what actually it is doing? It is dividing this quadrilateral into two triangles. If you notice, children, yes, it is divided into two triangles. So what will be the area then? So here the length of the diagonal AC is D. So AC equal to D, and let us drop a perpendicular from B on AC and mark it as H1. Similarly, we will drop another perpendicular from D on AC and mark it as H2. And these are the altitudes of triangle ABC and ADC. So ABC is a triangle, right? Now H1 will become altitude of triangle ABC and H2 becomes altitude of this triangle ADC. Now let us find out the area of this quadrilateral ABCD. Okay children. So which is nothing but area of triangle ABC. So area of this triangle, that is, you can see the green part, plus the area of triangle ADC. So this part. Okay children. So sum of these two areas will give you the area of quadrilateral ABCD. Now let us substitute the values of this and find the formula to find area of quadrilateral ABCD. So area of triangle is given by half into base into height. So area of triangle ABC is, I am assuming AC as the base. So what is the length of AC, children? D. So half into base is D, into altitude or height is H1. So into H1. Now what will be the area of triangle ADC, children? You are right. It is half into D into H2. Now again, do you notice anything common? Right. Or half into D. Now take out that half into D, children. You are left with H1 plus H2. So this is the formula to find area of quadrilateral. So let us summarize the formula. So area of quadrilateral is half into D into H1 plus H2. So what is D, children, here? Yes, it is the length of the diagonal. What is H1 and H2, children? They are the perpendicular drawn from the vertices on the other diagonal, right? Or I can say these two are altitudes. Okay. So area of quadrilateral is given by half into length of the diagonal into sum of the length of perpendiculars drawn from the remaining two vertices on the diagonal. Take a look at one example here. So find the area of a quadrilateral ABCD whose length of diagonal AC is 12 centimeters and the length of perpendiculars from B and D on AC are 7 centimeters and 6 centimeters respectively. Okay, so this is a figure drawn, and here the length of the diagonal is 12 centimeters given, and the altitudes which are drawn from B and D are how much? Yes, they are 7 and 6. So I am assuming H1 as 7 and H2 as 6 children. Now what is the formula to find area of quadrilateral? Yes, half into D into H1 plus H2. Now let us substitute these values now. So half into D is 12, H1 is 7 and H2 is 6. And here if you cancel 2 and 12 you get 6 into, this is 13, right, sum of these two. So 6 into 13 you get 78. So the area of the quadrilateral is 78 square centimeters. So next we are going to learn about area of rhombus. So this ABCD shown on your screen is a rhombus. Why do we call this as a rhombus? A rhombus is a four-sided figure in which all the sides are equal and the diagonals bisect each other perpendicularly. So this is a rhombus. Now let us assume the length of diagonals as D1 and D2. That means one of the diagonal AC is D1 and the other diagonal BD I take it as D2. So again if you notice, this diagonal AC is dividing the entire rhombus into two parts, that is two triangles, that is triangle ACB and triangle ACD. Now if I find the area of these two triangles and add, I get the area of the rhombus. Okay children. So in a rhombus we have already seen diagonal bisect perpendicularly, right? That means here OA and OC both are equal and OB and OD both are equal. Then what is area of rhombus given by? Yes, that is area of triangle ABC and area of triangle ADC. So let us substitute the values of area of triangles. So area of triangle is half base into height. So here what is the base I am assuming? AC. So if AC is the base, what is the height? OB. Again for this triangle also I am assuming AC as the base. So height will become OD. So substituting this, again anything common children? Half AC. Take out half AC common. Left is OB plus OD. Now from the figure children, what is OB plus OD? Yes, this total length, that is BD. So I can replace it with BD. So this becomes half into AC into this 2, sum of these two is BD. But what is AC children? Yes, it is D1. And what is BD children? It is D2. Now substitute the values, you get half into D1 into D2. So area of rhombus is given by half into D1 into D2 square units. So let us summarize the formula. So area of rhombus is given by half into D1 into D2, means its product of diagonals. So half into product of its diagonals. Take a look at an example. Find the area of rhombus whose diagonals are 15 centimeters and 9.8 centimeters. So here let us assume D1 as 15 centimeters and D2 as 9.8 centimeters. Area of rhombus is half into D1 into D2. Let us substitute the values children. So half into D1 is 15 into D2 is 9.8. On simplification we get 15 into, this goes 4.9 times, so 15 into 4.9 you get 73.5. Therefore the area of rhombus is 73.5 square centimeters. So children, we are going to look into another important and interesting thing, that is surveying a field. You might have seen the fields won't be exactly in a triangular shape or a rectangular shape or a rhombus shape like that. It is a combination of various fields, various shapes. Now how to find the area of such irregular figures? So we use surveying the field. Okay, a surveyor will be doing the survey of the field and is going to calculate the area of that field. So let us see how to calculate the area of the field. So a surveyor generally writes as shown on his book. If you can see, there is a surveyor's book. On that he will be entering the values like this, say from A to D like this. Then again some 30, 70, 110, 160, 200. I am taking an example of a field. Okay, and there will be some measurements written as shown on your screen. Now what do you understand by this? Let us see. So the data gives the information as shown here. So how many vertices are there, children, if you notice? 1, 2, 3, 4, 5 and 6. That is A, B, C, D, E and F. So there are 6 vertices. So if you join all these things, what do you get, children? Hexagon. So the field is in the shape of an hexagon. Then here if you notice, A and D are joined here. So we take it as a diagonal. AD is a diagonal. Then the vertices B and C are on one side of the diagonal, whereas the vertices E and F are on the other side of the diagonal. And if you notice, these are all the perpendiculars drawn from specific distances, like from 30, 70, 110, 160, so on. Okay, children. Then the last one, in the field book, the measurements are real and recorded from bottom to top. So always they are recorded from bottom to top, children. Now let us find out the area of this field, children. So children, before we exactly find the area of this field, it is important to draw the diagram of this field. Let us see how to draw the diagram. So first we will start from A and move to D. So this distance is how much, children? Yes, 200. Then from, say, at a distance 30, we are moving towards the right side. How much? 40. That point is D. And again at 70, we are moving towards the left, that is 25 to F. Again at 110, we are moving to right, that is 60 to C. Then at 160 again we are moving to left to E, a distance of 25. Now let us join all these vertices, children, A, B, C, D, E, F, and again coming back to A. Now if you notice, you got a closed figure, children, right? Now this is actually the shape of the field. Now we need to calculate the area of this field. Okay, children. Now if you notice, this field is divided into various plane figures, triangles, a rectangle and a trapezium, like that. So calculating the individual areas and adding, we get the area of this entire field. Now let us do that. Let us mark the points G, H, I, J as shown, children. Here from the figure, we have AG is equal to 30, GB is equal to 40, and HF and JE both are equal. If you notice here, both are equal to 25, and IC is equal to 60. Now area of this figure ABCDEF is given by area of triangle AGB plus the area of trapezium BCIG, then area of triangle CID plus area of trapezium ADEF. So children have divided this figure into 4 parts, that is 1, 2, 3 and 4. So sum of all these areas will give you the area of the entire field. Now let us calculate that. So area of triangle is given by half into base into height. So for the first one, half, I'll assume AG as the base and GB as the height. So half AG into GB. So similarly, what is the area of trapezium, children? Half H into A plus B. So we have here a trapezium, right? That is trapezium BCIG. So what is its area? Half into distance between parallel side IG into sum of parallel sides. What are the parallel sides here? GB and IC. So GB plus IC. Similarly, on substituting the area of triangle for the triangle CID, we get half into ID into IC. And for this entire trapezium, this bigger trapezium, it is half into JE into AD plus EF. Now let us find out the values here, children. Now here IG, if you notice, this IG, we don't know exactly the value of this IG. But IG is given by IA minus AG. So which is nothing but 110 minus 30 equal to 80. Similarly, we will calculate ID as AD minus AI, which is 200 minus 110 gives us 90. JH is equal to AJ minus AH. On substituting it, you get 90. Now let us substitute these values, children. Now if you notice, in these, we are going to substitute all the values now. So area of triangle is given by AG into GB. So I am substituting AG and GB values. So you get half into 30 into 40. Then here, substitute the values of IG, GB, IC. Here, we substitute ID and IC values. Then in this one, we are going to substitute JE, AD and EF values. Now let us simplify, children. So 2 goes in this 15 times, so 15 into 40. And here 2 goes 40 times, 40 into 40 plus 60, 100. 2 goes 45 times, so 45 into 60. Finally here 25 into 290 divided by 2, so you get 145. Now let us multiply all these children. So multiplying get 600 plus 4000 plus 2700 plus 3625. On adding all these things, you get 10,925. So therefore, the area of the field is 10,925 square meters. I hope you understood how to find the area of an irregular field, children. Till now we have learnt about, say, deriving the formula trapezium, rhombus, and also we have found out the area of an irregular field also. Now let us apply these concepts in solving few problems. Let us start with our first problem. The ratio of length of the parallel sides of a trapezium is 7:5 and the distance between them is 24 centimeters. If the area of the trapezium is 864 centimeters square, find the length of the parallel sides. Let us start with the solution. So given what is the ratio of parallel sides, children? 7:5. That is A is to B. I am assuming it as 7:5. So let us take A as 7x and B as 5x. And what is the distance between parallel sides, children? We denote it as h, which is given as 24 centimeters. And also it is given area of trapezium as 864 centimeters square. What is the formula to find area of a trapezium, children? Half h into a plus b square units. Now let us substitute all these values. So 864 equal to half into h is 24 into 7x plus 5x. So here 864 equal to half into 24 into 7x plus 5x is 12x. So 2 goes into 1 time and in 24 it goes 12 times. So what is left, children, now? Yes, 864 equal to 12 into 12x. So what is the value of x? 864 divided by 12 into 12, which is 144. On dividing this, you get 6. So we got the value of x as 6, children. What actually we need to find? The length of parallel sides, that is a and b values. So a is equal to 7x. Now substitute x equal to 6 here. So you get 7 into 6, 42. And b is how much, children? 5x. Substitute x is equal to 6 here also. You get 5 into 6, which is 30. Therefore, the length of parallel sides are 42 centimeters and 30 centimeters. Let us move on to our next problem. The following details are noted in meters in the field book of a surveyor. Find the area of the field if PR is 190 meters. So this is the figure shown, children. Okay, and the values are also given. We need to find the area of this field. Let us start with the solution. Area of PQRST is area of triangle PBQ plus area of triangle QBR plus area of triangle RCS plus area of trapezium SCAT plus area of triangle TAP. We need to find the areas of all these plane figures and just add to get area of PQRST, that is this field. Okay, children. So area of triangle is half into base into height, square units. Now let us take for this one a triangle PBQ. So it will be half into, say, PB into BQ. Then for triangle, say QBR, it will be QB into BR. So half into QB into BR. So like that, for triangle RCS, it is half into SC into CR, and we have area of trapezium. What is the formula, children? Yes, half h into a plus b square units. Now let us substitute this half into distance between parallel sides is AC into what are the sum of parallel sides? AT plus SC, AT plus SC, and plus we have the last triangle, that is TAP. So that is half into base is PA, height is AT. Now let us substitute all these values, children, now. So on substituting, you get half into 60 into 70 plus half into 90 into 60 plus half into 30 into 30 plus half into 90 into 40 plus 30 plus half into 40 into 40. Let us simplify them. So this goes 30 times, so 30 into 70, plus this goes 45 times, so 45 into 60. This goes 15 times, so 15 into 30. This goes 45 times, so 45 into 40 plus 30 is 70. And finally this goes 20 times, so 20 into 40. Now let us multiply them, children. 2100 plus 2700 plus 450 plus 3150 plus 800. Let us add all these things. On adding, you get 9200 square meters. So this is the area of the field, children, which is 9200 square meters. I hope you understood the problem. Let us move on to our next problem, children. The floor of a building consists of 2000 tiles which are rhombus shaped, and each of its diagonals are 36 centimeters and 25 centimeters in length. Find the cost of flooring if each tile costs 25 rupees per meter square. Let us start with the solution. So this is a tile, children, and the diagonals are given. So diagonals are 36 centimeters and 25 centimeters. So we'll assume it as D1 36 centimeters and D2 25 centimeters. Let us find out the area of this tile, which is in the shape of a rhombus, that is given by half into D1 into D2 square units. Let us substitute the values, children. Half into 36 into 25. So 2 goes into 1 time, whereas in 36 it goes 18 times. On multiplying 18 and 25, you get 450. So this is the area of one tile, right, children? But how many tiles are there? We have 2000 tiles. So what is the area of 2000 tiles? 2000 into 450. On multiplying this, you get the number as shown, but it is in centimeter square, children. But here the cost is given per meter square. So let us convert this into meter square. So for that, we divide by 100 into 100. On dividing it, you get 90 meters square. The cost of flooring is 25 rupees per meter square. Therefore, what is the cost of 90 meters square, children? Yes, 25 into 90. On multiplying this, you get 2250 rupees. I hope you have understood the solution clearly. So children, till now, the area of trapezium, quadrilateral, and also polygon, right? And also we have seen few examples. Now before we end our session, let us quickly recap what we have learned in this session. Area of triangle is half into base into height square units. Area of rectangle is L into B square units. Area of a square is side into side S into S square units, whereas area of parallelogram is base into height. Area of trapezium is half H into A plus B. Area of quadrilateral is equal to half D into H1 plus H2. Area of rhombus is half into D1 into D2 square units. The area of a polygon may be obtained by dividing the polygon into a number of simple shapes. So children, we have seen what actually we have learned. We had a quick recap of what we have learned. I want you to do some problems which are based on the concept that we have learned just now. Let us see those problems, children. Area of a trapezium is 64 centimeters square. Length of one parallel side is 6 centimeters and the distance between two parallel sides is 8 centimeters. Find the length of the other parallel side. Find the area of rhombus whose diagonals are 12 centimeters and 16 centimeters. Find the area of each of the following fields. All dimensions are in meters. So children, with this, we come to the end of our session. I hope you have learnt all the concepts clearly. I want you to learn all the formulae and apply these formulae in solving the problems that are given in this session. Thank you for watching the digital class. Have a great day.
Telangana, the youngest and the fastest growing state in India, is scaling new heights. Telangana soon started ticking the right boxes. The seeds of innovation were sown at a young age. 𝗬𝗃, the Hyderabad startup ecosystem anchor, is among the first such initiatives to institutionally build a startup innovation ecosystem. 𝗬𝗃 was created to nurture women entrepreneurs, help them grow and scale up operations. T-Works is formed to reduce the barrier for hardware prototyping and extend help to master their hardware prototype. RICH, RICH. RICH facilitates research, reaches the market. Task, to enhance skilling among the youth. Task will skill them so that they become robust entrepreneurs, and TSIC to simply create more and more innovators. The central theme is to create a unique model of innovation for the state. Adding to this, the progress in curriculum and entrepreneurial culture at educational institutions are also said to have contributed to the growth of the state startup ecosystem. Telangana has also embarked on a journey to make Digital Telangana a reality. T-Fiber, or the Telangana Fiber Grid, envisions to establish a state-of-the-art digital network infrastructure across the state. Since the formation of state in 2014, the IT exports grew at a CAGR of 15.67%. Exports saw a 220% growth since 2014. For the financial year 2021-22, Telangana's IT/ITES exports touched Rs 1,83,569 crore, a whopping increase of 26.14% over the previous financial year. The rise of Rs 38,046 crore from 2020-21 is the highest in a single year since state formation. As per NASSCOM, India's total IT/ITES exports grew at 17.20% during the financial year 2021-22. Telangana recorded 9% higher growth rate in IT/ITES exports than the national average. In 2014, when the state was formed, 3.23 lakh people were employed in the IT sector. Telangana IT/ITES employment witnessed an impressive 140% growth since 2014. During financial year 2021-22, Telangana added about 1,50,000 new jobs, taking the total IT/ITES employment to 7,78,121, an year-on-year increase of a phenomenal 23.78% compared to 2020-21. As per NASSCOM, the Indian IT/ITES sector added 4,50,000 new jobs in financial year 2021-22. With 2.5 times more indirect jobs created, about 20 lakh people are dependent on the IT sector. As envisioned in the second ICT policy 2021-26, Telangana is well on its course to achieve Rs 3 lakh crore exports and 10 lakh jobs. With new players coming in, Hyderabad saw a demand for office space rise. Hyderabad topped Bengaluru in office space absorption for 2 quarters. The government of Telangana has unveiled Rural Technology Centres policy for the growth and development of Tier 2 cities and rural areas. The IT department is developing dedicated towers and incubation centres across Tier 2 and Tier 3 locations, with a target to generate employment to 25,000 professionals by 2026. Telangana offers the best-in-class infrastructure and progressive and friendly government policies that is resulting in new and repeat investments from MNCs. Further, Hyderabad boasts of stable government, cosmopolitan culture, mature business ecosystem, and high quality of living.
This mission has been taken up in the state of Telangana in the year 2020, I believe, Is it in 2020 July? I think 2020 July, this mission has been adopted and taken up by the Indian Institute of Military Research based at Hyderabad under the leadership of our principal scientist, 𝗧𝗦𝗔𝗧. I have also visited, happened to see that also along with some farmers. I visited earlier, and ever since it has been focusing to see that the farmers are tracked and